make your own polynomial function. So what we've just done is solve polynomial functions. Now we're going to make them. So we're going to go backwards. So here we have these zeros, 5 and minus 2. Well, if you had originally this, if you had x minus 5 is equal to 0 and added 5, you would get x equals 5. But originally this was parentheses x minus 5. That's why whenever you have the 0, when you put it in parentheses, you have to use the opposite sign because it's going backwards. It's like now subtracting 5 and bringing it back over here. Okay, that's just an example to show how we do or why we do the opposite. And that means this becomes an x plus 2. So all we really have to do is multiply these out. The function of x is equal to x minus 5 times x plus 2. So let's multiply this. X times x is x squared plus 2x minus 5x minus 10. So the function of x is equal to x squared minus 3x minus 10. And that's it. We have just made, from just the two zeros, we have made a polynomial. Okay. Now let's do it again, and this time we're going to do it with an imaginary number. Okay. Whoa, there's a whole bunch of ones on here. That's a big one. But here's the first thing to know. Paired. Well, I want to write this better. So make the what's called conjugate. The conjugate is the opposite number with it. So if you have negative 2i, then you also have, let me get the word also in there. Also have positive 2i. So as another example, if we had 7i, we would also have negative 7i. Or if we had negative 23i, we would also have positive 23i. So those are just examples there. Well, what that means now, let me get this back down a little bit, okay, is that I actually have 3, negative 5, negative 2i, and positive 2i. So you have to add this one yourself. Add this one yourself. Make a note of that. This is the one of the important ones. Otherwise, you don't get the right polynomial. So now let's turn those into a polynomial. The function of x is equal to x minus 3, because we have to use the opposite sign. X plus 5, the opposite sign. And it's minus 2i, so it's x plus 2i. And then we have x minus 2i. Okay, now I'm going to show you a little trick with the second two. So think of this as a plus b and a minus b. That means my answer will be a squared minus b squared. And if a is x and b is 2i, that means I'm going to have x squared minus 4i squared. And I becomes a negative 1 and makes it x squared plus 4. Let me walk you through it without doing it with that way. But let's do these first because you want to do the ones with the imaginary numbers first to make it a little easier because some of the things will cancel out. 2ix plus 2ix minus 4i squared. Notice that these cancel out. So I get x squared minus 4i squared. I squared equals negative 1. So I have x squared minus 4 minus 1. And that means I have x squared plus 4. So this becomes this. And now I'm going to put these other ones in here. X plus 5, x minus 3, and f of x is equal to that. Well, it doesn't really matter now which way I want to multiply these out. I think I'll multiply the first two, and then we'll do more with it. So let's do equals x squared, function of x equals x squared plus 5x minus 3x minus 15. And I still have x squared plus 4 here, but now I have to clean up this. X squared plus 2x minus 15. And x squared plus 4. So it'll be a little easier. I have that over here for multiplying. So I'm going to do that. X squared plus 4. Don't have to, except to me it's a little easier. Plus 2x minus 15. So now I'm going to multiply these. This time this, and this, and this, and then this time this, and this, and this. So the function of x is equal to x to the 4th. Well, I think I'm going to have a little bit more. Plus 2x third to the 3rd minus 15x squared. And then plus 4x squared plus 8x minus 60. Okay. And a couple of these I can combine, like namely these two. So here the function of x is equal to x to the 4th plus 2x to the 3rd minus 11x squared plus 8x minus 60. So notice what you have to do with all those imaginary numbers. You have to recognize first that you add that one yourself. Then here we multiplied them out. Okay, so that came down and became that. And then I can multiply the rest of it. It's actually just multiplying a whole bunch of polynomials at that point, which isn't really hard, just gets a bit tedious, I guess you could say. That's the best word to use. It gets tedious. All right. So now let's look at another example problem. Write a polynomial of least degree with integral coefficients with the zeros -3, 1/2, and 6i. Now this one's going to have another technique. First thing I notice is that I also have -6i. Okay. So let's go ahead and do the function of x is equal to x plus 3, x minus 1/2, x minus 6i, and x plus 6i. I want to talk about this one for a moment, okay? Because now what I want you to see is that if you have a denominator, this can be rewritten as 2x minus 1. They count as the same thing. And that's usually easier to work with. Reason for that is if I have x minus or equals 1/2, if I have x equals 1/2, I can subtract that from both sides and I can get x equals -1/2. Or x equals 1/2. I can multiply both sides by 2 and get 2x equals 1, and then subtract 1 and get 2x minus 1 is equal to 0. So both of these are the same thing. All right, or minus 1/2. Oh, I meant to bring that around, so it was x plus 1/2 equals 0 right over here. So these two count as the same thing. And it's easier to work with that way. So people who want to leave something as a fraction can do that, but I'm not going to. I'm going to take care of these two first, because I know that gives me x times x is x squared. -6ix plus 6ix go away, so it's -36i squared now. That is the same as -1, so I actually have a squared plus 36. And 2x minus 1. Now let's multiply out some more. Now I'm going to do these. I'm going to get x squared. Oh, it's 2x squared. Okay. Minus 1x plus 6x. Okay, I think that's a lot, so I think I'll just do, so I just did this one, 2x squared. Then I do minus x. Here I do plus 6x. Here I do minus 3. Let's put those together as a plus 5x. Check my negatives on there. And minus x plus 6, that's 5x. That looks right. And a minus 3, or negative 3. Good. Now I'm going to multiply that out. And this time I'll just do it this way. I'll do that. So that's 2x to the 4th. And then to this one, plus 72x squared. And now it's this one, plus 5x to the 3rd. And then we'll go to here, plus, 150, 180x. Wow, okay, there's a bunch of them there. Okay, 100, oops, I forgot the 0. Actually, now let's write that a little bit better. 180x, and now here, minus 3x squared, minus 108, 90 and 18. Okay. Now I have to combine some like terms. And so there's only one fourth term, 2x to the 4th. But then there are, is there only one third term? It looks like there is only one third term. So it's plus 5. What is it? Wait a second. Let me double check here. So I have another cube. Okay. So I did this times that and that times that. That's a 5x cubed. And negative 3 squared. It looks like that's the only one. I feel like I'm missing something in one of these, but maybe I'm not. Squared, 36, 72x squared. Okay. And that's x cubed. Negative 3x squared. I don't see any other way to do it. So I have a 5x cubed. And I have two of them that are x squared. So it looks like that's plus 69x squared. And then the 180x, I think I need to move that better. 180x minus 108. Okay. So 3x squared, this looks pretty good. And 43210. So again, look at having to add that, knowing then that you could change this one into this, knowing to multiply these so you get the I squared and make that a plus, right? And then the rest of it, you just do the rest of the work carefully, multiplying everything out. Okay. And you end up with that polynomial. Okay. Well, that is it for these things. Let's just quickly look back at the beginning. The first part of this is some of the almost easiest way now to solve these, to get the solutions and to state what kind they are. And this one in C, it's good to see that you'll have an imaginary one done in this way. This method or this technique here helps to make it easier to solve a bunch of the problems. And in this one, we had to do the factors of P and Q. And that technique is really helpful for finding a possible solution set. And from those, picking the ones to do long division with. Okay, and then we did the same thing here. Okay, so we have a couple of ways to do it there. In this case, with the quadratic formula. And in this case, we didn't have to use the quadratic formula. We could do that. And then it was make your own polynomial. First without imaginary numbers, and then with imaginary numbers in these examples. All right. I hope that was helpful. Thank you for watching and listening.